And we're back. All right. Hey everyone. Today we're out here in the frozen tundra because I can't think of a better place to talk about Python freezing. Python freezing, of course, is being the process of taking your Python project, your script, your application, and turning it into actual software. Imagine this scenario. You're a developer and you know you have something big. You know that get humans to Mars.py is going to change the course of humanity. The only problem is not everyone has Python installed. Not everyone is a developer. Not everyone knows how to set up all the dependencies and get that working. You want something that you can just give to your everyday user and they can just run and use it like they would any other piece of software they've worked with. Freezing is the solution. My thesis for today is that Python freezing is awesome. Also, Python freezing kind of sucks. So in this video, I'm going to go over what Python freezing is. I'm going to go over a few of the most popular libraries for doing so. I'm going to show you an example of how to freeze an application using my favorite library. I'm also going to go over some of the pain points and my own personal recommended workflow for getting your project from just a script into an actual piece of software. I want to emphasize I am not an expert and I don't claim to be. I'm just on my own journey, learning to code better, and I hope that some of the things I've picked up along the way can help somebody else out too. So that's why we're doing this. Let's go ahead and let's dive in. What is freezing? This comes down to the difference between compiled and interpreted software. A compiled piece of software, say something written in C, your source code gets thrown through a compiler, magic happens, and machine code comes out. This is something your computer can run more or less directly. An interpreted piece of software, which Python is an interpreted language, you have your source code and it needs to be run through an interpreter at runtime in order for the application to work. Generally speaking, interpreted software is slower than compiled software. So why do we do interpreted software? Well, you need to ask yourself, what are we optimizing for? If you are optimizing for speed, I don't think an interpreted language is the way to go. However, I'm going to argue that computers are really fast these days, and that's probably not the major constraint on most software these days. It's probably developer time. It's probably your own creativity and even just knowing what to build and how to build it. I think that Python, part of the beauty of it is optimized for those ideas. It's not optimized for speed, but that's not the constraint placed upon most projects. So in that sense, I think using an interpreted language makes a lot of sense. So what is freezing in that sense? Freezing is basically the process, to speak simply, of taking an interpreter, taking all the dependencies that your project needs, and just kind of bolting it to your Python project, and then having all that run at runtime. By and large, this process works surprisingly well. So what are some of the most popular libraries for this? The first one I want to talk about is cx_freeze, cxfreeze. This is a really good library. One of the big advantages of this one is that I live my life in the Windows world. You can take your project and you can have it exported as a .msi installer. So that is to say, you can, with this one library, you can go from a Python project, just a .py file, into an actual Windows installer, all in one step. If you can get that to work, that is outstanding, fantastic. I've had pretty good luck with cxfreeze. I'd say it's my second favorite library. However, I've found that when projects grow in complexity, this has just not worked for me all that well. However, I've just found that as projects grow in complexity, the reliability of cxfreeze, it's just not as reliable as my favorite library. It's a good one though. You should definitely check it out if you're sort of experimenting, figuring out which one you want to use. A PyOxidizer is another interesting one. This is one I have limited experience with. I think it's kind of underrated by the community, however. I would think about using PyOxidizer if you want a single file executable. That is, you don't want an installer, you don't want an executable next to a folder with a bunch of dependencies in it. You just want one executable. And if your project is kind of big. What libraries like PyInstaller do, they essentially zip up all your dependencies and attach it to the executable. So then when you run it, it extracts all of these files, puts it in a temporary directory, and then runs it from there. PyOxidizer doesn't do that. It's much, much faster at startup. So if you have a project that you want to be a single file executable, it's relatively large or complex, this is probably a good library for that use case. Nuitka, I'm not sure if I'm pronouncing that correctly, is somewhat unique. It might not even belong in this conversation. It is not a true form of Python freezing. It is actually an entirely new Python compiler. So at the beginning, I talked about the difference between compiled and interpreted languages. Nuitka kind of blurs those lines, and it allows you to compile your Python. That has advantages for IP protection. It's going to obfuscate your source code. It also can be more performant because you're just running a compiled program. In my experience, this is an amazing library. We're so lucky to have this as part of the Python ecosystem. However, I've only personally been able to get it to work for relatively simple projects. Complex projects, I have not been able to get it to work. That's probably on me. I could probably bang my head against a wall and get this to work. However, I have not personally been able to achieve that. And all this leads us to my personal favorite one, the one that I personally recommend you use, which is PyInstaller. This is probably the most popular one online, and I think for good reason. The reason for that is just whatever magic these libraries do behind the scenes in terms of getting dependencies, PyInstaller just seems to be the best. I have had so much luck, even with complex projects, of just using it and it just working. So, I'm going to go through a project real quick, just an example of using PyInstaller to freeze an application. My last video, I'll link it in the description, was experimenting with small tools. If you don't watch the video, it's no big deal. Small Tools is a really cool project put out by Hugging Face that allows you to run a large language model locally on your machine. You know, I just have kind of a crummy like $300 laptop here and it runs just fine. So you can go to GitHub, get this project. I have it pulled up in PyCharm here. It's insanely bright out, so I can actually barely see my screen. But, you know, let's just run this real quick. Very good. Up and running. A little awkward with my mic here. Cool. So it works with function keys, which unfortunately other applications use the function keys. But this is an example, so it just popped up a chat window. So tell me a short story. So it's using a 1.7 billion parameter large language model, and it's running on CPU inference with a low-powered laptop. Pretty cool, pretty cool. However, say you wanted to use this on another computer, or you had a friend who's not a developer that wants to use this. They're not going to know how to download this off of GitHub. Also, this even happened, I got this project working a few days after it dropped. The dependencies were already broken. I had to dig around and figure out which version of which package to use to get this working. That's not acceptable for a standard user. So you're going to want to freeze this. I'm going to close this, stop that. So in your terminal, very simple, you're going to want to pip install PyInstaller. I already have it installed. But for you, that'll install PyInstaller. Then it's really easy. Just pyi-make spec. This is demo_tkenter.py. That is going to make a spec file. You're going to do py installer, demo, tk enter. It is so bright. .spec. And then we're just going to run this. This is going to take a while. You can look at the py install. I'm trying to do the simplest version of this today, which would work for most use cases. The settings right out of the box are very good. There are all kinds of settings you can dive into. Py installer is pretty powerful. For example, you can do it as I'm going to do it as a one directory version today. You could do it as one file. You can set a custom icon. You can make it run with or without a console. Those are kind of the standard options that I typically mess with. It's powerful. It's a great library. Okay. And just like that, we've converted a relatively complex Python project into a Windows executable. Python freezing is awesome. So let's go to the dist folder. And let's run demo tk enter. It didn't work. Python freezing sucks. So what happened, if we were able to read that error, the llama CPP library, for whatever reason, did not make it into the final folder there. So what we're going to do, the more elegant way to do it is you can include llama CPP into your build instructions. There's ways to do that. You can look at the PyInstaller documentation. However, another way to do it is to simply grab it from your virtual environment, copy it, paste it into this internal folder. Suddenly, we have a running version of this. We have a Windows executable. It works. And just like that, we're able to open it up. It is running as a Windows executable without too much fuss. Very, very cool. Python freezing is awesome. So, that was just a brief rundown of freezing in Python. To summarize, I'm going to go over my own personal workflow and recommendations for how to get a relatively complex Python project frozen. I typically don't have huge .py files. I'll have kind of a simple entry point, app.py, and it is reaching for other modules with functions and methods that I've written. I like to Cythonize those. It's beyond the scope of this video, but Cython is a very powerful library. I'll make a video about in the future that essentially converts your .py files into .c files. This has advantages for speed. It also has some advantages for code obfuscation. A dedicated, sophisticated user can always figure out your source code. But it's kind of nice to not make it dead simple. It's kind of like putting a cheap like on your, It's kind of like putting a cheap lock on your bike. I like to just do that if you care about your source code. There's nothing wrong with people understanding your source code and just putting it out there. But if you want to obfuscate it some way, there's an option there. After using Cython, I use PyInstaller, like I just showed you, and I create a one directory output. Just to show you again, the general format is this .exe, an executable file, and then right next to it is an internal file with a ton of library or a ton of folders in it. One of the pain points of Python freezing, which once again, Python freezing, this is an example of how it sucks. There's going to be stuff in here that you don't need. PyInstaller made, I think, the good decision. They clearly made a subjective decision behind the scenes to be conservative. they just want your application to work. So they err on the side of putting the kitchen sink. They put everything in this directory. This is great because most projects are small and you don't really care if there's extra junk there. You just want it to work. So this is optimized for that. It's fantastic. However, if you're trying to create a more legit commercial piece of software, you don't want to be shipping just junk in this folder. Unfortunately, I am not aware of a better process than trial and error. Literally just look at these folders, maybe sort by the one with the most files in it. Some of these are going to be obvious that you definitely need it. Some of them you're going to be like, I don't even know what this library is. Delete the folder and try to run your application. I know that sounds janky. It is. The more complex your software gets, you're going to need to do a lot of testing to make sure you don't need this. It's the best process I know. You can then exclude that library in the build instructions. So that is one of the downsides and pain points of all this. Once I've got it all pared down, I sign the executable with a code signing certificate, and then I use inosetup to package it all into a .exe traditional Windows installer. I've shown that in previous videos. I can do another one in the future talking about that. If you don't have a code signing certificate, that's okay. A easier way to do it is you can get an SHA 256 hash of your file and show that on your website or your GitHub next to the installer so users can check that, make sure they got the same file that you intended for them to get. That's sort of a easier way to do the same thing. So, in summary, guys, that is my overview of Python freezing. I hope you learned something. I had a great time sitting out here with the geese, making this video. Thanks for watching. Have a good rest of your day.